All right, welcome back. Next, let's add a method called find or search or whatever you want, contains node. Basically, the idea is that you have a binary tree and you can search to see if a value is in that tree. So you could search to see if 50 is in a tree or 100 is in a tree. And the process is very similar to inserting, in a binary search tree at least, because we have those rules, the greater than to the right, less than to the left. So we can cut about half the tree away each comparison that we make. So for example, when we go to insert a number, like let's say we're inserting 7 into this list. Let's do that quickly. Insert the number 7. All right, we compare it. It's less than. It was very fast. We checked once we got to 11. Was there a left? Nope. Well, that's where 7 goes. Now, if we're doing the same thing, but searching for 7, I'll go slower this time. We do the exact same steps. We check, all right, is this 7? No. So it's less than. Okay. So we need to look on the left. Is this 7? 20 is not 7. So 7 is less than again. So we look on the left. Is this 7? Nope. It's 11, but we know that 7 is less than 11, so we look to the left. And what do you know? We found 7. So we return true or return the node. We're just going to do true or false to see if we found it, if it contains that value. And if we were inserting something that isn't in there, if we're searching for something that's not in there, like let's say we're searching for 75. Go. All right, we start here. Is this equal to 75, the root? Nope. 75 is greater, so it's going to be over here if it's in here on the right side. So we get to the next node. All right, is 75 equal to 65? Nope. It's greater than, so it's going to be over here on the right. Okay, so we look. Now we have 91. Well, 75 is less than 91, so we need to look to the left. Then we get to 72, and now 75 is greater than 72, so we know it needs to be on the right, but there is no right. So that means it's not in here. If we find the point where we basically hit the end of the tree on one branch and there is no next, there's no right when we're looking for a right, or there's no left when we're looking for a left, that tells us the value is not in there, assuming our tree is set up correctly. I mean, if for some reason 75 was over here incorrectly, of course, we're not going to find it because we're not checking every single node. That's the point of the binary search tree. We know the order that things are stored in. We know how it's structured, so we can take advantage of that and do a much faster search. Okay, so in this case, we would return false or return null, and this is what they're showing. So the basic steps: start at the root, check if there's a root. If not, we're done because there's nothing in there. If there is a root, check the value of the new node, see if it's equal to what we're looking for. If you found it, then we're done. If not, check to see if the value is greater than or less than. If it's greater, look to see if there's something to the right. If there is, move to that node and repeat the same steps. If there's not, that means that we're done. Same thing on the left. So I'll walk through it one more time. If you feel good to go, try and implement it on your own. It's very similar to what we did in the last video with insert. It's just actually a little simpler. Let's say that we're searching for 40. We're going to start here, 41. All right, 40 is less than 41. So we look to the left. We get to 20. Well, 40 is greater than 20. We check, is there something to the right? Yes. So then we start the loop over. Is 40 equal to 29? No. So we check, it's greater than. So is there a dot right? Yes. So we move down here and start the loop over. Is 40 equal to 32? Nope. So then we check, is there something to the right because 40 is greater than 32? No, there is not. That means we didn't find it. We return false. So those are the basic steps. Go ahead. You don't have to follow the pseudocode to the T. It doesn't contain every bit of information. For example, we want to have probably a while loop. And I would make a variable called found and a variable called current or start or some sort of variable to keep track of where you are, and then a variable that you'll set to true or false that will stop the loop. So when you find it, the loop should stop, or if you hit the end, then you should return. Okay, give it a shot.